Bismillahirrahmanirrahim. Assalamu alaikum, everyone. Welcome to another episode of ISNET's podcast series. I'm Sadaf Sajjad, Administrator ISNET, and your host for today's conversation. In our previous episode, we interacted with the innovative students from Jordan who have self-started the journey of developing CubeSats and are looking forward for its launch. To continue the CubeSat topic further, in today's episode, we are diving deep into the world of innovation with the brilliant minds behind team of recently successfully launched and deployed CubeSat of Pakistan, iCube-Q. Without further ado, let's meet our esteemed guests, the faculty and students of Institute of Space Technology who worked on iCube-Q. Leading the project is Dr. Kamrul Islam. Then we have Dr. Khurshid and Khurshid and students Mr. Saeed Faisal Ahmed and Mr. Sikander Zulfiqar. Thank you so much for being here today. Sir, to start off, my question is with Dr. Kamrul Islam. Sir, can you provide our audience with an overview of what iCube-Q is and the impact it aims to make?
Okay, thank you, Sadaf, for having me. So basically, iCube-Q is a class of satellites. They're called CubeSats. They are miniature satellites primarily developed by education institutes and research institutes to send those in orbit and test new technologies or some innovative ideas. So it's an economical way to go to space. And that's why most of the leading universities who actually research in the space actually send CubeSats satellites. And we started our journey with CubeSats with our iCube-1, which we developed and we launched in 2013. And that was in low Earth orbit. And after that, we actually worked with APSCO, which is Asia Pacific Space Cooperation Organization, for another project, which was a bigger one, 3U CubeSat, which was launched in 2021. And as you know, we have a good relations with China, and China's Chang'e 6, actually they plan to go to moon for a sample return mission. And they had space for international payloads. And this was offered through APSCO, and we actually competed for that in iCube series, and then we named it as iCube-Qamar, which Qamar is for moon, so that's how it's called iCube-Q. And one more thing I just want to say is that although this is a CubeSat, it's not a standard CubeSat because of the volume and the space available. So it's what you can call is a very customized kind of CubeSat. More in terms of the mass, you can classify as a CubeSat. Otherwise, there are so many additional requirements associated with the timelines were also very critical because fixed timeline to go in space. So we had to meet all those requirements in terms of the timelines. So this is a very brief intro of the iCube-Q.
Thank you for highlighting these important aspects about iCube-Q. Dr. Khurram, what are some of, if you can tell us that what are some of the key technical innovations or unique features of iCube-Q that distinguishes it from other CubeSat? Dr. Qamar has also touched this topic, but if you can also further elaborate on this.
Yeah, sure. Thank you very much, Sada. So as Dr. Qamar said, it's a bit different from standard CubeSats. If I show you, this is a standard CubeSat, single unit CubeSat. It's 10 centimeter, 10 centimeter, and 10 centimeter. So all three sides are 10 centimeter. It's called a 1U CubeSat. So basically, this particular CubeSat that we had launched, it's for the moon orbit. So when we are sending a satellite to a deep space mission, there are certain requirements that we have to fulfill. As Dr. Qamar already mentioned, the electronics, the material selection for the structure, it has to be such that it can sustain the harsh environment of deep space for the moon. So this was one particular aspect that you can say differentiates from the other CubeSats. So one is the size. It's approximately 7 kgs in mass, and the dimensions are also a little bit different from the standard CubeSat. So that's the main differences. Yeah.
Okay, thank you, Dr. Khurram. Dr. Qamar, if I come to you once again, that given the complexities of satellite technology, how did your team collaborate and coordinate during the development and the launch phases of iCube-Q?
Yeah, this is a very good question. Actually, the Chang'e team, which is developing the Chang'e, so Chang'e has got a number of components, and one of them is the orbiter. Then we have a lander and a sender and all that. So within the CNSA or China National Space Agency, there are different agencies actually working on different areas. We had to work with all of them, like the China Lunar Exploration Program. Then we have Lunar Center. Then we have other space Shanghai Flight Center. So they are responsible for different things. So then we had meetings with so many of them for each particular aspects. So obviously we were really very busy in actually when we doing the initial design. That was pretty challenging because there were a lot of restrictions there. Because I can give you an example that, for example, the moon does not have its own magnetic field, so we cannot use magnetic torques for attitude control. Similarly, there are some other constraints that were put in. So we were designing this under all these sense. So we actually, as we went along with the different meetings with them, we actually modified our designs. Then the detachment of the satellite from the orbiter was also a pretty challenging one. They didn't want much thrust coming back to the orbiter. So we did a lot of tests for that when the space was very limited in terms of the release mechanism. So all those things were quite challenging, and but I must appreciate the Chinese side, because whenever we requested them, they were very busy with their own work. They always gave us time so that we can actually continue our work. And as the time came near and near, and we got busier and busier, and many qualification tests, and so yes, this is how it actually happened.
Yes, indeed. When collaborating with an international organization, or when there are two international entities, obviously there are many challenges, but really it's commendable that how you overcome those obstacles and able to launch this successful satellite. So now my question is to our students, Faisal and Sikander. If you guys can briefly describe your specific role in the iCube-Q project and how your contributions help to achieve the mission's goal.
Being an electrical engineer, my task was to develop and test the communication subsystem for the iCube-Qamar, and the second major contribution was to develop a software which was used for the ground station. So our satellite is actually communicating through our communication subsystem, which is actually based on X band. So we are successfully communicating with our satellite through the ground station and through our communication subsystem. So these were some of the major contribution of mine in iCube-Q project.
Well, my primary role was to design attitude control of satellites. Plus, I also actively involved in ground software development for iCube-Q. So it's our big achievement till because the data from satellite is still coming on our on software, and we can easily integrate with it and see the what current attitudes and parameters. So up till now, it's our development. So I would like to say we're still working on this project and we'll work on analysis whenever our mission is completed and we are in good position to go where our satellite in the future when we are supposed to write any research article and future students it will be easy for them to develop their own iCube satellite. So this will be a prime you can say a prime objective and reason for for the future students to develop their own iCube satellite.
So basically, if the students were selected by seeing their educational background, the degree, and then they were assigned for a specific task, was that so, Dr. Khurram and Dr. Qamar?
Yes,
if Dr. Qamar,
yeah. Yes, the GARAs were actually selected based on their background. And then obviously they were given the tasks. For example, somebody given a task to design an antenna and test an antenna, and somebody is given both of these Sikander and Faisal. They actually put a lot of effort in developing. The software with our other supervisors in Suparco as well. So the Suparco's contribution is there also. So they actually are worked on the telemetry software and currently the software that we are using our ground station in Islamabad and Lahore. So they are still actually working on getting it more visually better and all that sort of thing. So yes, they are actually their selection is based on their background. So Sikander is an aerospace engineer, so I think more fit for to model the attitude control and Faisal is on electrical side, so antennas and communication side is his area. So that's why they were given the tasks to do that work.
And I'm sure
and I would like to also add that there are also other students who are also working. Some are like mechanical engineers who are working on the structure part of the system, materials engineer for the selection of materials, a space science student, computer science student that is working on the onboard computer software. So for the selection of students, Dr. Qamar led the process, and me and also Dr. Rehan, we were part of the interview panels, and we selected the students based on the requirement. For each subsystem, we required different set of expertise, and that's how different students were selected for this particular project.
That was, I'm sure, must be a difficult task as well. You know, the competitive procedure, it must have been a competitive procedure. And Faisal and Sikander, you should be proud of yourself and to other students as well for being part of this project. My other question to Faisal and Sikander is that if you can tell us some of the most valuable skills and lessons you have learned while working on this project.
Yes, as my task was to develop say a subsystem, communication subsystem for the iCube-Qamar. So the system that we were designing were especially based on space applications, because in the space application, if you can see, there is a lot of environment difference between the Earth and the space. So we were looking for such kind of components and systems that we can use for the deep space communications. So for that we had guidance from our instructors, Dr. Qamar and Dr. Khurshid, who had guided us to develop such kind of systems. So actually the main skills that we have learned were actually designing such kind of system that can be used for the deep space networks. So these were some of the major skills that we have learned from our supervisors and our Dr. Qamar and Dr. Khurshid.
as a slide, I had worked on attitude control. So what we have studied in bachelor's, I actually did in this in a practical iCube satellite with hands-on experience connecting the software simulations to hardware by STM32 IDE. So it actually gives me a confidence to on the person who has bachelor's. So gives me a good exposure hardware side as well. Plus, on the top of it, I also been engaged with the cross-functional team like Faisal from the communication satellite from electrical major and some other from like other person from mechanical engineer. So it gives me a good communication skills and cross-functional skills. So at the end of the day, it's actually a good experience for all of us.
That's great. Thank you, Sikander and Faisal. Dr. Qamar, if you can tell us that what type of data will iCube-Q collect and how do you plan to utilize this data for scientific, environmental, or technological applications?
So generally, whenever a space system goes and starts operation, so with time it actually degrades, and that's how we actually determine the life of that satellite. So around the Earth, in low Earth orbit or in geostationary, depending upon the environment, the degradation varies depending upon, for example, the solar cells, depending on the radiation, their efficiency goes down. Similarly, for some electronic components can get affected. We have got a lot of data that is coming and with over time, now it's already a month, so the satellite is already covered, like I've done 58 orbits in space, and as the data, we get more and more data, we'll see how each of the subsystem is performing, and that will give us good information of the moon environment and how it differs around the Earth. And we actually see each subsystem's performance in terms of the design, and as time goes by, how actually they hold on to such environment, which will be helpful for any future mission, and also like the orbital dynamics of, because gravitational model of the moon and the Earth are different. So we'll see that how stable the orbit remains over time. Right now it looks stable, and so so there are a lot of information that we, and obviously for the imaging side, they will be taking images of the moon, and especially one with the closest one, we be analyzing. Dr. Khurram and his team, which are the expert on image analysis, they'll be doing work on the imaging side. So there's a lot of work that we have as long as, I mean, the satellite is operating, and we hope it exceeds the design life, and we have a satellite around the moon for quite some time.
Inshallah, and I hope the studies that you are telling us about are beneficial, turns out to be beneficial, inshallah. Dr. Khurram, I'm sure the audience must also be curious about the challenges you have encountered along the way. So if you can briefly tell us about some of the challenges that you have faced and how you people have addressed them.
Yeah, definitely. For a project of this magnitude, during the journey, we faced certain challenges. The main challenge was the strict timeline. Actually, we got this project, we won this project from EBSCO in 2022, start of 2022, and the timelines were very strict because the launch of Chang'e 6 was already fixed for May 2024, and thus the timeline, we had to follow each and every step according to the timeline. So certain challenges, like during procurement, we faced certain challenges. We wanted to acquire some components from some European vendor, but due to time delays, we looked for other options as well. So to overcome this sort of challenge, we were always looking at multiple options to see if we can get this thing from vendor A or vendor B, whichever gives us quicker, and the thing is according to our specifications as well. So I can say this was one of the biggest challenge. Then secondly, qualification tests. As you know that once the satellite is ready, it has to pass certain qualification tests before it can be integrated with a bigger satellite, bigger mission, Chang'e 6. So to overcome this challenge, we underwent certain qualification tests, some in IST, some in Suparku, Lahore. There are some testing facilities in Suparku, Lahore as well. And then the final integration and tests that we went through in China before the integration. So all these steps were successfully completed. There were some, you can say, glitches in the way, but we overcame all those challenges successfully at the end. And once the satellite was it passed all the tests, that was a major, you can say, achievement or milestone for us that, okay, the satellite is now ready and the Chinese launcher has accepted it and it can now be integrated. So this was another challenge. Another challenge was budget. So initially, once we got the budget in 2022, after that, the exchange rate, the price hike in dollar. So all that also affected like how we went through and how we procured certain components. So these were our certain challenges, but at the end, we overcame these, and Alhamdulillah, the project was successfully completed.
It is truly commendable that how you and your team overcome these challenges. Looking ahead, what are your aspirations as follow-up of iCube-Q, and where do you see it heading in the coming years? Dr. Qamar, if you may please answer this.
Okay, so as I said earlier, that actually, in fact, the actual data analysis of how our systems are doing is a very important thing. That we were going to learn a lot of things from that for designing any future programs. For example, if you want to have a longer duration satellites around the moon or maybe another celestial body. So I think that is one very important thing. And secondly, for any other future opportunities that we get, similarly, we want to even have to do it a slightly bigger one as well. With more payloads. We actually initially had 4 or 5 payloads in mind, but because of the restrictions there, we had to reduce that. So going forward, if we get the opportunity, we would like to have a more bigger and complex satellite which can perform many other tasks as well. And also we would like the students to involve at different levels. So that we have time and we are more prepared that even if the future opportunity comes, that we are ready for that. And so I think that is an important thing. So each subsystem we develop now should be such that when the future opportunity comes, then we can actually do it faster, and those problems that we had this time we're not going to face that. So we are definitely looking forward to more projects. Actually, there is one opportunity to Pakistan in Chang'e 8 as well, and if we get the chance, we will definitely going to actually utilize that.
Our best wishes to you and your team for achieving these targets. We will conclude our today's podcast by asking a question from the students, Faisal and Sikander. What advice would you like to give to other students who are interested in getting involved in space projects, but they are actually unsure as to where to start from?
Actually, I will suggest our students to keep in touch with the space communities, because there are a lot of space communities that are operating on the social media. If we talk about here in the IST, there are so many space communities, space labs we have SSTR lab and SSL lab, where there are a lot of researchers which are working on different payloads and different satellites. So if we keep in touch with such kind of researchers, we can achieve our goals. And I will advise our students, if you do not have any resources in the universities or in your institutions, you can go on the social media, and there are a lot of resources provided on the social media, so you can achieve your goal through social media. And this is what I would advise our students, and they can achieve their goals.
Precisely, I would say the concepts like linear algebra, differential equations, probability, and statistics, these are the most important aspects the current students need to strongly grasp on it, because as from my side, control side, we are barely need that transformation from one frame to another. So we need to have good understanding of all these concepts like linear algebra. And also on the top of it, I would like to say that students need to have good command on programming languages like Python, MATLAB, and C++. Python and MATLAB are high level and easy to start. So students can start on these languages, then they can jump to C++, because real systems are based on C++. So I would, at the end of the day, I would like to say that these both like programming languages and mathematics, they need to have good understanding, and they must know how to integrate with the real system.
Great. Where you people highlighted the main areas that the students should focus on. So thank you, Dr. Qamar. Thank you, Dr. Khurram, Mr. Faisal, and Mr. Sikander for sharing your insights and experiences with us. Your dedication to innovation is truly inspiring. We look forward to witness your continued success and eagerly anticipate for the next chapter in Pakistan's journey in space, inshallah. And thank you, audience, for joining us. And until next time, keep dreaming big. Goodbye for now. Allah Hafiz.